Today we are going to discuss inverse Laplace transforms. In the previous chapter, we have learned Laplace transforms. So, their Laplace of f of t is equal to f bar of s. So, inverse Laplace transform, what it says is L inverse of f bar of s. L inverse of f bar of s is nothing but the function f of t. So this is the Laplace transform. This is the inverse Laplace transform. So let us consider one example. So Laplace of e power at. Laplace of e power at is equal to how much? 1 by s minus a. Therefore L inverse of 1 by s minus a is equal to e power at. This is the inverse Laplace transform. So this is the basic definition. Law of f of t is equal to f bar of s. Then L inverse of f bar of s is equal to f of t. So Laplace of e power at is equal to 1 by s minus a. Then L inverse of 1 by s minus a is equal to e power at. So these are the basic concept of inverse Laplace transform. Now we are going to discuss some problems related to, not the problems, basic formulas related to the inverse Laplace transform. Okay, the first formula is L inverse of 1 by s. L inverse of 1 by s. L inverse of 1 by s, this is the important formula, that is equal to 1. So similarly L inverse of 1 by s power n plus 1, L inverse of 1 by s power n plus 1 is equal to t power n by n factorial. So if s power n plus 1, then t power n by n factorial. So if it is s cube, then here it is come across with t square by 2 factorial. Suppose here it is s power 5, then t power 4 by 4 factorial. Okay. Similarly, third formula L inverse of 1 by s minus a. L inverse of 1 by s minus a is equal to e power at. Next formula L inverse of 1 by s plus a is equal to e power minus at. Similarly, L inverse of 1 by s square plus a square is equal to 1 by a sin at. 1 by a sin at. Similarly, L inverse of s by s square plus a square is equal to cos at. Similarly, next formula L inverse of 1 by s square minus a square is equal to 1 by a hyperbolic sin at. Similarly, next formula L inverse of s by s square minus a square is equal to hyperbolic cos at. Hyperbolic cos at. So these are the basic formulas. These are the basic formulas regarding the L inverse Laplace transform. So L inverse of 1 by s is equal to 1. L inverse of 1 by s power n plus 1 is equal to t power n by n factorial. L inverse of 1 by s minus a is equal to e power at. L inverse of 1 by s plus a is equal to e power minus at. L inverse of 1 by s square plus a square is equal to 1 by a sin at. L inverse of s by s square plus a square is equal to cos at. L inverse of 1 by s square minus a square is equal to 1 by a sin at. L inverse of s by s square minus a square is equal to hyperbolic cos at. So similarly, next we are going to discuss one problem, basic problem. Okay. So what the problem is? L inverse of 3 into s square minus 2 whole square by 2s power 5. 2s power 5. Okay. So first you consider the inner part, that is equal to 3 into s square minus 2 whole square by s power 5. 2 into s power 5. So first you simplify this one. 3 into s square minus 2 whole square, s power 4 plus 4 minus 4 a square plus b square minus 2ab means 4s square whole divided by 2 into s power 5. This you can write it as 3 by 2 into s power 4 by s power 5. 1 by s plus 4 by s power 5 minus 4 into s square by s power 5. 1 by s cube. 1 by s cube. Now you apply the inverse both sides. L inverse of 3 into s square minus 2 whole square by 2s power 5 is equal to 3 by 2 into L inverse of 1 by s plus 4 by s power 5 minus 4 by s cube. This is nothing but 3 by 2 into L inverse of 1 by s plus 4 into L inverse of 1 by s power 5 minus 4 into L inverse of 1 by s cube. Okay. So this is nothing but 3 by 2 into L inverse of 1 by s is nothing but 1 plus 4 into L inverse of 1 by s power 5 t power 4 by 4 factorial minus 4 into L inverse of 1 by s cube t square by 2 factorial. So if you simplify this one, you are going to get the answer. 1 plus 4 into t power 4 by 4 factorial minus 4 into t square by 2 factorial. So next we will consider one more problem. Okay. So that is equal to L inverse of s square plus 9s minus 9 by s cube minus 9s. S cube minus 9s. Okay. So if you consider the inner part, this s square plus 9s minus 9 by s cube minus 9s. This you can write it as s square plus 9s minus 9 by denominator you take common s. Therefore you left with s square minus 9. So the denominator you have s square minus 9. Numerator also you try to get s square minus 9. S square minus 9 plus 9s. Okay. Whole divided by s into s square minus 9. This you can write as a. This is considered the one term and this is considered the other term. Therefore 1 by s plus 9 by s square minus 9. Okay. So now you apply the Laplace inverse both sides. L inverse of s square plus 9s minus 9 by s cube minus 9s is equal to L inverse of 1 by s plus 9 by s square minus 9 you can write it as 3 square. 9 you can write it as 3 square. So this you can write it as L inverse of 1 by s plus 9 into L inverse of 1 by s square minus 3 square. That is equal to L inverse of 1 by s is equal to 1 plus 9 into L inverse of 1 by s square minus 3 square. That is means 1 by a. 1 by a means 1 by 3 hyperbolic sine 380. Okay. So if you simplify, you are going to get the answer. Okay, these are the basic problems in the inverse Laplace transforms. Okay, today we are going to discuss inverse Laplace transforms using partial fractions. So solving inverse Laplace transforms using partial fractions. So first problem is L inverse of s square by s plus 1 into s plus 2 into s plus 3. Okay, so we don't have any direct formula for this one. Okay, so what we have to do is this s square by s plus 1 into s plus 2 into s plus 3, you have to write it as the summation of the terms. So this you can write it as a by s plus 1 plus b by s plus 2 plus c by s plus 3. So now you take the LCM both sides, and then you are going to get s square is equal to a into s plus 2 into s plus 3 plus b into s plus 1 into s plus 3. Similarly, c into s plus 1 into s plus 2. So now you substitute the in place of s some values. So put s is equal to minus 1. So then what happens? So the left hand side, you can say this one as equation 1, this one as equation 2. So substitute s is equal to minus 1 in the equation 2. So left hand side minus 1 whole square means plus 1 is equal to, so this term will vanish because s plus 1, this term will vanish. Therefore a into minus 1 plus 2, 1 minus 1 plus 3 is plus 2. That implies a is equal to 1 by 2. Similarly, put s is equal to minus 2. So this term will vanish and the last term will vanish. Therefore, you left with the middle term. S is equal to minus 2 means s square means 4. So here b into minus 2 plus 1 minus 1 minus 2 plus 3 plus 1. That means b is equal to minus 4. Similarly, put s is equal to minus 3. So this s plus 3, this term will vanish, this term second term will vanish, you left with the third term. S square means 9. So c into s plus 1 minus 3 plus 1 minus 2. So minus 3 plus 2 minus 3 plus 2, it is minus 1. That implies c is equal to 9 by 2. Therefore, if you substitute all the values of a, b, c in the equation 1, therefore you will get s square by s square plus 1 into s square plus 2 into s square plus 3 is equal to a by 1 by 2 into s plus 1 plus b means minus 4 by s plus 2 plus c 9 by 2 into s plus 3. Therefore, you apply the inverse both sides. L inverse of s square by s square plus 1 into s square plus 2 into s square plus 3 is equal to 1 by 2 into L inverse of 1 by s plus 1 minus 4 into L inverse of 1 by s plus 2 plus 9 into L inverse of 1 by s plus 3. So if you simplify, you are going to get 1 by 2 into e power minus t minus 4 into e power minus 2t plus 9 into e power minus 3t. Okay. So this is the solving inverse Laplace using the partial fractions. Now we will consider one more problem. Okay. S L inverse of s square by s square plus 4 into s square plus 25. Okay. So now you consider the inner part s square by s square plus 4 into s square plus 25. Okay. Now we will consider the 1 by s square plus 4 into 1 by s square plus 25. So this you can write as 1 by s square plus 4 minus 1 by s square plus 25. So if you do like this, the numerator will left with 21. So to compensate 21, you divide with 21. You will get like this. Okay. So in the next step, we need s square by something. Therefore, s square by s square plus 4 into s square plus 25 is equal to 1 by 21 into s square by s square plus 4 minus s square by s square plus 25. Now you apply the inverse Laplace both sides. L inverse of s square by s square plus 4 into s square plus 25 is equal to 1 by 21 into L inverse of 1 by 21 into L inverse of s square by s square plus 4 minus s square by s square plus 25. Okay. This you can write it as 1 by 21 into 1 by 21 into L inverse of s square plus 4 minus 4 by s square plus 4 minus s square plus 25 minus 25 by s square plus 25. That is nothing but equal to 1 by 21 into L inverse of 1 by s square plus 4. Sorry, 1 not 1 by s plus 4. It is s square by s square plus 4 means 1 minus 4 by s square plus 4 minus s square plus 25 by s square plus 25 means 1. Just minus into minus plus 25 by s square plus 25. Okay. So this plus 1 and minus 1 will get cancelled. Therefore 1 by 21 into L inverse of you left with 25 by s square plus 25 minus 4 by s square plus 4. Okay. So that is nothing but equal to 1 by 21 into 1 by 21 into 25 into L inverse of 1 by s square plus 5 square minus 4 into L inverse of 1 by s square plus 2 square. Therefore what you left with is 1 by 21 into 25 into So 1 by s square plus 5 square, 1 by 5 sin 5t minus 4 into 1 by 2 into sin 2t. Okay, so 5 times 2 2 times. So what you left with is 1 by 21 into 5 sin 5t minus 2 sin 2t. So this is the way to solve the inverse Laplace using partial fractions second model. Okay, today we are going to discuss inverse Laplace transforms, second shifting theorem. Inverse Laplace transforms, second shifting theorem. I shortly written it as SST, second shifting theorem. So what it says, the second shifting theorem, what it says is so L inverse of e power minus as into f bar of s is nothing but equal to the f of t minus a into u of t minus a. This is the statement of the second shifting theorem. So this is the statement of the second shifting theorem. Okay, shifting theorem. So you remember it as, so how you are going to get this value, how you are going to get the a value, how you are going to get the value. Here it is a, this a you are writing here. Okay, this a you are writing here. Okay, so now we will discuss one problem. So what is that problem is nothing but the, so L inverse of e power minus 3s by s minus 4 whole square, s minus 4 whole square. Okay, so this you can write it as L inverse of the standard form e power minus 3s into 1 by s minus 4 whole square. So now it is in the form of L inverse of e power minus as into f bar of s. Okay, so a value is how much? A is equal to 3. Okay, so now I will solve the problem. So except this L inverse of e power minus 3s, we do the Laplace of this one. Therefore L inverse of 1 by s minus 4 whole square, L inverse of 1 by s minus 4 whole square, that is equal to L inverse of means e power 4t into L inverse of 1 by s square, that is nothing but e power 4t into, it is nothing but t. Okay, e power 4t into t, this is nothing but L inverse of f bar of s is nothing but equal to, we are getting f of t. So this value is nothing but equal to the f of t. Second step, what we will do is the second step, L inverse of e power minus as, e power minus 3s into 1 by s minus 4 whole square. Okay, how we will get this one? What he is saying is f bar, f of t minus a, a means 3, t minus 3 into u of t minus 3, but f of t value is e power 4t into e power 4t into t. Therefore e power 4 into t minus 3 into again t minus 3 into u of t minus 3. So this is the L inverse of so and so using second shifting theorem. Okay. Today we are going to discuss second shifting theorem. One more problem. Okay, second shifting theorem. Okay, one more problem. We are going to discuss one more problem. So what is that problem is L inverse of 1 plus e power minus pi s pi s by s square plus 1 elements of so on so. So this is nothing but L inverse of 1 by s square plus 1 plus L inverse of e power minus pi s into 1 by s square plus 1. So this this is nothing but in the form of L inverse e power minus as into f bar of s where f bar of s is equal to 1 by s square plus 1. So L inverse of f bar of s is equal to L inverse of 1 by s square plus 1 is equal to sin t. So that is nothing but f of t value we are getting is sin t. Second step, what we have to do is L inverse of e power minus pi s into 1 by s square plus 1. So integral inverse of e power minus pi s means f of t minus pi into u of t minus pi. So f of t minus pi means sin of t minus pi into u of t minus pi. Okay. Third step, L inverse of 1 plus e power minus pi s by s square plus 1 is equal to sin t plus sin t minus pi into u of t minus pi. This is the answer. Okay. Similarly, we can do one more problem. What is that one is L inverse of e power 4 minus 3s by e power 4 minus 3s by s plus 4 whole power 5 by 2 s plus 4 whole power 5 by 2. Okay. First step, what we can write it is as L inverse of e power 4 into e power minus 3s to 1 by s minus 4 whole power 5 by 2. Okay. E power 4 into L inverse of e power minus 3s into 1 by s minus 4 whole power 5 by 2. So this is in the form of L inverse of e power minus as into f bar of s. So where f bar of s is equal to L inverse of f bar of s is equal to L inverse of f bar of s is nothing but f of t is equal to L inverse of f bar of s Here f bar of s is equal to 1 by s minus 4 whole power 5 by 2. That is equal to 40 into 1 by s power 5 by 2. It is equal to e power 40 into t power 3 by 2 by 3 by 2 factorial. Okay, now L inverse of e power 4 minus 3s by s minus 4 whole power 5 by 2 is equal to f of t minus a into union of t minus a. F of t minus a means e power 4 into a t minus 3 into t minus 3 whole power 3 by 2 by 3 by 2 factorial. Okay, today we are going to discuss inverse Laplace transforms first shifting theorem. Okay, so we are going to discuss first shifting theorem. Okay, first shifting theorem, what it says is L inverse of f bar of s is equal to f of t, then L inverse of f bar of s minus a is equal to e power at into f of t. Okay, so if you know this one, you can solve the problems. So first we will consider one problem. So that problem is find the Laplace inverse of 1 by s plus 2 whole square plus 16. Okay, so this problem is in the model. In place of s we have s plus 2, therefore you have to use the first shifting theorem. So this is simply you can write it as e power minus 2t into L inverse of 1 by s square plus 4 square. Okay, so e power minus 2t into Laplace inverse of s 1 by s square plus 4 square, that implies 1 by 4 into sine 4t. So this is the answer we are going to get. Okay, so next we will consider one more problem. Okay, so that problem is s 3s minus 2 by, find the Laplace inverse of 3s minus 2 by s square minus 4s plus 20. Okay, so first what you have to do is, here in place of s you don't have s minus 2 or s plus 2, so on and so forth. So what you have to do, this problem you have to convert into a first shifting theorem model. Okay, for that one, here it is minus 4s is there, you divide with this minus 4s with 2, how much you are going to get? S coefficient is 2, that means you can write it as L inverse of 3s minus 2 by s minus 2 whole square. You divide with 4 with 2, how much the coefficient of s is 2, therefore you can write it as s minus 2 whole square plus how much you have tried. Let us consider s square plus 4 minus 4s. Okay, so how much you have to add? 16 you have to add. Okay, this is nothing but L inverse of, so here denominator is s minus 2, so numerator also in place of s you write it as minus 2, so therefore 3s minus 6, 3s minus 6. So how much you have to add? Plus 4. So minus 6 plus 4 minus 2. Therefore 3 into s minus 2 plus 4 by s minus 2 whole square plus 4 square. So how much we are going to get is nothing but so in place of s you have the s minus 2. Therefore applying the first shifting theorem, e power 2t into L inverse of 3s plus 4 by s square plus 4 square. So this is nothing but equal to e power 2t into L inverse of 3 into L inverse of s by s square plus 4 square, s by s square plus 4 square, plus again another term, next term 4 into L inverse of 1 by s square plus 4 square. So this is nothing but e power 2t into 3 into L inverse of s by s square plus 4 square. That means cos 4t plus 4 into L inverse of 1 by s square plus 4 square, 1 by 4 into sin 4t. So 4 4 will get cancelled. So you left with e power 2t, 3 e power 2t cos 4t plus e power 2t into sin 4t. So this is the answer, e power 2t into sin 4t. So next we will do one more problem on the transforms of derivatives. Okay, transforms of derivatives, what it says is first we will discuss. Okay, so L inverse of f bar of s is equal to f of t, then L inverse of nth derivative of f bar of s is equal to minus 1 power n into t power n into f of t. Okay, this is the inverse Laplace of derivatives. So first we will consider one problem. So what is that problem is log of s1 plus 1 by s square, log of 1 plus 1 by s square. So you consider the first step, this entire one you consider the f bar of s. F bar of s is equal to log of 1 plus 1 by s square. Okay, second step, you simplify this one. So what it will happen is log of s square plus 1 by s square. This you can write it as again log a by b model, means log a minus b, log s square plus 1 minus 2 log s. Now you have to do the differentiation. Okay, so f dash of s is equal to log s square plus 1 differentiation means 1 by s square plus 1 into 2s minus 2 by s. So first you f bar of s you have simplified, next one f dash you have did the differentiation. Third step, you do the Laplace inverse. Laplace inverse of f dash of s is equal to 2 into L inverse of s by s square plus 1. Okay, 2 into L inverse of s by s square plus 1 minus 2 into L inverse of 1 by s. So that is equal to 2 into L inverse of s by s square plus 1. L inverse of s by s square plus 1 means cos t minus 2 into L inverse of 1 by s means 2. This you can write as 2 into cos t minus 1. So fourth step, so L inverse of f dash of s means nothing but minus 1 power 1 into t into f of t is equal to 2 into cos t minus 1. Okay, so next step what happens, fifth step what happens is therefore f of t is equal to 2 by t into 1 minus cos t. So this is the how to find the Laplace inverse using the derivatives. So most of the problems you come across with logarithms or tan inverse or cot inverse, you always have to use the derivatives. So this is the given problem. So this is the given problem, log 1 plus 1 by s square. First step, you consider this one entire one, it is f bar of s, and you have simplified the problem. Okay, next step what you did is you do the differentiation of the f bar of s, one time differentiation. Next what you did is the inverse, Laplace inverse, L inverse is the third step. Okay, so f bar first step is the simplification. Okay, simplification of f bar of s. Second step is the differentiation. Okay, third step is the L inverse, applying the L inverse. Next one is the applying the derivative formula. So you got the final answer. Okay, so next one we are going to do one more problem, that is L inverse of we are going to do one more problem, that is L inverse of tan inverse a by s plus cot inverse s by b. Okay, first step what you have to do, then you have to consider f bar of s is equal to you have to consider it as tan inverse a by s plus cot inverse s by b. So in the second step what you have to do is differentiation. You do the one time differentiation. Tan inverse a by s differentiation means 1 by 1 plus tan inverse x 1 by 1 plus x square. X square means a square by s square into a by s differentiation. A into 1 by s differentiation is minus 1 by s square plus cot inverse s by b differentiation minus 1 by 1 plus x square 1 1 plus s square by b square into s by b differentiation. So 1 by b you are going to get. So third step so this f dash of s you simplify, so what you are going to get is the, so denominator is s square plus a square, numerator you have the s square, here s square will get cancelled, so you left with minus a minus, so b square in the numerator and b in the denominator, therefore numerator left with 1b by b square plus s square, b square plus s square. So first what we did is the next one is the applying the L inverse. L inverse of f dash of s is equal to minus L inverse of a by s square plus a square. Okay, similarly minus L inverse of b by s square plus b square. Okay, so this is nothing but minus a by s square plus a square sin at minus sin bt. Okay, so fifth step, L inverse of f bar of s means minus 1 into t into f of t is equal to minus of sin at minus sin bt. Okay, therefore f of t is equal to sin at minus sin bt by t. Okay, so this is the f of t, nothing but the L inverse of f bar of s value. Okay, so first what you did is in the first step, so first step this is the given step. Okay, f bar of s. So second step what you did is you did the differentiation. So given one is the first step, second step is the you did the differentiation. So third step is the you have did the simplification, fourth step is applying the L inverse, so fifth step is the derivative formula. Okay, so this is the way to solve the inverse Laplace transforms using the some derivatives. Okay, today we are going to discuss convolution theorem based problems. Okay, today we are going to discuss convolution theorem, convolution theorem based problems. Okay, so when you can use the convolution theorem means, so you remove it as product of two transforms. So if product of two transforms, okay, so in this case we will use the convolution theorem. So we will discuss L inverse of, let us consider f bar of s into g bar of s is nothing but f of t into g of t. Okay, so already we know the f of t into g of t is nothing but integral 0 to t f of u into g of t minus u into du. So convolution theorem statement is nothing but the L inverse of f bar of s into g bar of s is equal to f of t into g of t. But the product f of t into g of t is nothing but integral 0 to t f of u g of t minus u into du. So let us consider one problem, first problem. Okay, so L inverse of 1 by s plus a into s plus b. Okay, L inverse of 1 by s plus a into s plus b. So first what you have to consider, this is nothing but the L inverse of 1 by s plus a into 1 by s plus b. Okay, so this is product of the two functions, two transforms, 1 by s plus a into 1 plus s plus b. So okay, so first you consider it as the first one, f bar of s as 1 by s plus a, g bar of s you consider it as 1 by s plus b. Okay, next what you have to do is that you have to apply the L inverse both sides. So L inverse of f bar of s is equal to L inverse of 1 by s plus a. So L inverse of 1 by s plus a is nothing but e power minus a t, and L inverse of f bar of s is nothing but f of t. Similarly, apply the L inverse to g bar of s. L inverse of g bar of s is equal to L inverse of 1 by s plus b. So g bar of s means g of t is equal to e power minus bt. G of t is equal to e power minus bt. So now apply the convolution theorem. So L inverse of 1 by s plus a into 1 by s plus b is equal to L inverse of 1 by s plus a into 1 by s plus b is equal to integral 0 to t f of u e power minus a into g of t minus u e power minus b into t minus u into du. Okay, now we will do the simplification of this term, integral 0 to t into integral 0 to t into e power minus au into e power minus bt into e power minus minus into plus e power bu du. Okay, so this you can write it as integral 0 to t, okay, e power minus au. So e power minus bt is independent of this one, therefore you can write it this one as outside of the integration. E power minus bt into integral 0 to t e power minus, you take common, you take common, you left with b minus a, b minus a du. So that is nothing but e power minus bt into integration of that one is nothing but e power u into b minus a, okay, by b minus a. between the limit 0 to t. So e power minus bt into, now you substitute in place of ut, therefore e power t into b minus a by b minus a minus, if you substitute 0 in place of u, so e power 0 1 1 by b minus a. Okay, so if you do the simplification of this one, e power minus bt by b minus a into e power bt in into e power minus at minus 1. So this is nothing but e power minus bt plus bt will get cancelled, therefore e power minus at minus e power minus bt by b minus a is the answer. So first, how to do this type of model problems is, so given problem is L inverse of 1 by s plus a into s plus b. Okay, 1 by s plus a into s plus b. So L inverse of product of two terms I have written. So standard converted into the standard model. So f bar of s you and g r bar of s you will get f bar of s and g bar of s. Next, applying the L inverse, applying the L inverse both sides, applying the L inverse both sides, writing f bar of s comma g bar of s is the second step, applying the L inverse the third step. So you will get f of t value and g of t value. So next one, applying the convolution theorem, applying the convolution theorem, convolution theorem, applying the convolution theorem. Therefore you are going to get integral 0 to t f of u into e power f of u into g of t minus ut. So if you do the simplification, we will get like this. Okay, similarly we will do one more problem, that is L inverse of 1 by s square by s square plus 4 into s square plus 9. Okay, you do this problem. Okay, today we are going to discuss applications to ordinary differential equations. Okay, applications to ordinary applications to ordinary differential equations. So now we consider one problem. So using Laplace transform method, solve d square plus 1 into y. Okay, d square plus 1 into y is equal to 6 cos 2t. T is a positive number and y is equal to 3, dy is equal to 1 when t is equal to 0. He has given when t is equal to 0. So first step in solving this problem, so d square means y double dash plus y is equal to 6 cos 2t, 6 cos 2t. So y is equal to 3 and dy is equal to 1 when t is equal to 0. That means you can write this one as y of 0 is equal to 3 and dy means y dash. So y dash of 0 is equal to 1. Okay. Second step, applying the taking the Laplace transforms. So taking Laplace transforms both sides. So taking Laplace transforms both sides. So what happens? L of y double dash plus L of y is equal to 6 into Laplace of cos 2t. Okay. So third step, so L of y double dash, you apply the formula. L of y double dash means s square into L of y minus s into y of 0 minus y dash of 0 plus Laplace of y is equal to 6 into Laplace of cos 2t. Fourth step, you substitute the values of y of 0 and y dash of 0. So y of 0 is how much? 3. Y dash of 0 is equal to 1. You substitute these two values here. So therefore s square into L of y minus y of 0 is equal to 3. Therefore minus 3s minus y dash of 0 minus 1 plus L of y is equal to 6 into Laplace of cos 2t. Now you take L of y as common. Therefore L of y, if you take common, you left with s square plus 1 is equal to 6 into Laplace of cos 2t plus 3s plus 1 plus 1. Therefore sixth step, therefore L of y is equal to 6 into Laplace of cos t means s by s square plus 2 square. Okay, s square plus 2 square into s square plus 1 plus 3s by s square plus 1 plus 1 by s square plus 1. Okay, seventh step, therefore L of y is equal to this one. How you can write that one means 1 by s square plus 1, 1 by s square plus 4. So if you sum minus, let us consider. Therefore what happens, s square plus 4 minus s square minus 1. So what here I am doing, s square plus 4 minus s square minus 1. So s square will get cancelled, 4 minus 1, 3 you left with. What, how much we require? The numerator is 6s. Okay, so then it is better one is s by something. So what happens, s cube plus 4s minus s cube minus s. So s cube will get cancelled, 4s minus s, 4s minus s, 3s. So it is, now it is better to multiply with 2. Okay, so plus 3s by s square plus 1 plus 1 by s square plus 1. Eighth step, now you apply taking the inverse Laplace transforms both sides. So what happens, L of y, inverse means y is equal to 2 into L inverse of s by s square plus 1 minus 2 into L inverse of s by s square plus 2 square. Okay, minus 2 into L inverse of s square by s square plus 2 square plus 3 into L inverse of s by s square plus 1 plus L inverse of 1 by s square plus 1. So this is nothing but equal to 2 into L inverse of s by s square plus 1 means s by something means cos t minus 2 into cos 2t plus 3 into L inverse of s by s square plus 1. S by s square plus 1 means cos t plus 1 by s square plus 1 means sin t. Therefore 2 cos t plus 3 cos t, 5 cos t, 5 cos t minus 2 cos 2t plus sin t. So this is the y value. So y is equal to, what you left with is 5 cos t minus 2 cos 2t plus sin t. So what are the different steps we have is the first one, given problem in terms of y dash and y double dash. Second one is the taking Laplace transforms both sides. So now you applying the L of y double dash and formula. Fourth step is the substituting the values of y of 0 and y dash of 0. Next step is the taking L of y as common. Next step is L of y is equal to something. Next one, 6x by s square plus 2 square into s square plus 1. I have split it into partial fractions. Next one, taking inverse Laplace transforms both sides, you will get the next step. Therefore finally this is the answer. Okay, next we will go for one more problem. d cube y by dt cube plus 2d square y by dt square minus dy by dt minus 2y is equal to 0. Y of 0 is equal to 1, comma y dash of 0 is equal to y double dash of 0 is equal to 2. So first step, so d cube means y triple dash plus 2y double dash minus y dash minus 2y is equal to 0. Okay, so next one you apply the Laplace. So L of y double dash plus 2 into L of y double dash minus L of y dash minus 2 into Laplace of y is equal to 0. L of y triple dash means s cube L of y minus s square into y of 0 minus s into y dash of 0 minus y double dash of 0. So this entire one is the expansion of the L of y triple dash plus 2 into L of y double dash means s square into L of y minus s into y of 0 minus y dash of 0. So this is the expansion of L of y double dash minus L of y dash means s into L of y minus y of 0 minus 2 into Laplace of y is equal to 0. Now the next step, fourth step is substituting the values of y of 0 is equal to 1, y double dash of 0 is equal to y of 0 is equal to 1, y dash of 0 and y double dash of 0 is equal to 2. So s square into L of y minus s square into y of 0 is 1. Therefore minus s square, y dash of 0 is equal to 2, y dash of 0 is equal to minus 2s minus y double dash of 0 is equal to 2 plus 2 minus 2 into again 2 into s square L of y means 2s square L of y minus 2s into y of 0 is equal to 1 minus 2 into y dash of 0. So y dash of 0 minus 2s into L of y plus 2s square L of y minus 2s into y of 0 is equal to 1 minus 2 into y dash of 0. y dash of 0 is equal to 2. 2 into 2 4, therefore minus 4 minus s into L of y, minus into minus plus y of 0. So y of 0, y of 0 means how much? This one, y of 0 is equal to y of 0 is equal to 1, therefore plus 1 minus 2 into Laplace of y is equal to 0. In the next step, what it is better one is L of y times s square into L of y, 2s square into L of y, s into L of y, 2 into L of y. Therefore L of y you take common, what you left with is s square plus 2s square minus s minus 2 is equal to the remaining terms you move to the right hand side, s square plus 2s plus 2 again plus 2s plus 2s plus 4 minus 1 is equal to minus 1. So that is nothing but equal to s square plus 2s 2s 4s plus 6 minus 1, it is plus 5. S square plus 4s plus 5 by s square plus s cube, this is s cube, L of y into s cube plus 2s square minus s minus 2 s cube plus 2s square minus s minus 2. This is the L of y value. So next step, taking the inverse Laplace transform, y is equal to, so L inverse of this one, L inverse of s square plus 4s plus 5 by s square plus 4s, sorry, s square s square got s cube plus 2s square minus s minus 2, y is equal to this much. This you can write it as L inverse of s plus 2 whole square, s square plus 4s plus 4, so s plus 2 whole square plus 1 by, you in denominator you take s as common, s square s, if you take common, s cube if you take s square if you take common, s plus 2, s plus 2, from this one if you take minus as common, s plus 2. So that is nothing but L inverse of s plus 2 whole square, s plus 2 whole square by s plus 2 into s square minus 1, s square minus 1. Therefore if you do the simplification, s plus 2 whole square by s plus 2 into so and so. So if you do the 8th step, you are going to get L inverse of s plus 2 by s square minus 1, first step, plus s plus 2 by so and so, s square minus 1 into s plus 2. L inverse of s plus 2 by s square minus 1. As if you do the simplification, you will get the answer. Okay, thank you very much. Today we are going to discuss convolution theorem. Okay, so the statement what it says is Laplace of f of t into g of t is equal to f bar of s into g bar of s. This, in other words, you can write it as L inverse of f bar of s into g bar of s is equal to f of t into g of t. Both are the same. So this is in terms of the Laplace. This is in terms of the L inverse. Okay. So how to prove this one? This convolution theorem. First you considered phi of t. Let phi of t is equal to f of t into g of t. But the convolution product f of t into g of t is nothing but integral 0 to t f of u into g of t minus u into du. Okay. So next you consider taking Laplace transforms. So Laplace of phi of t. So by the standard definition of Laplace of f of t, so we can write as integral 0 to infinity e power minus st into phi of t into dt. But this again you can write as integral 0 to infinity e power minus st into phi of t is nothing but this one. Phi of t, in place of phi of t you have tried this one. This one you have tried, that is nothing but integral 0 to t f of u into g of t minus u into du and dt. Okay, this one you are going to get. So that is nothing but here. So both integrals, integral nothing but 0 to infinity, integral 0 to t. Okay, e power minus st into f of u g of t minus u du dt. Okay, du dt. These are the t limits. T is equal to 0 to infinity. These are the u limits. U is equal to 0 to t. Now changing the order of integration. Changing the order of integration. Changing the order of integration. How the limits will be? Changing the order of integration. So now you consider this is t and this one is u. So here t is equal to 0 to infinity. T is equal to 0. T is equal to 0 means this line. T is equal to 0. T is equal to infinity means somewhere else here. Okay. So 0 to infinity means you will get our area will be here. Okay. T is equal to 0 to infinity. Next one u is equal to 0 to t. U is equal to 0 means this line. U is equal to 0. U is equal to t means this line is called the u is equal to t. That means this is the area we require. This is the area we require. So now you have to change the order of integration and all. So that means first one you have to write it in terms of u, and then inner integral you have to write in terms of the t. In terms of the t. Okay. Now so now if you consider in a horizontal strip, let us consider this is the horizontal strip. Let us consider. Okay. So here the point is what t is equal to u. So t is equal to u. So t is equal to infinity. Okay. t is equal to u to infinity. So then u varies from which value to which value? U varies from which value to which value? So u varies from u is equal to 0 to u is equal to infinity. So e power minus st into f of u into g of t minus u into du dt. Okay, this again you can write as u is equal to 0 to infinity e power minus su into f of u into du into integral t is equal to u to infinity e power minus of this is nothing but e power minus s into t minus u into g of t minus u into du. That is nothing but here minus st e power minus st plus su. Therefore e power plus su e power minus su will get cancelled. We left with e power minus st. So okay. So this one, if you observe this one, you can write in another model. This t minus u you treat it as v. Therefore t minus u is equal to v. Okay. So dt is equal to dv. Okay. Next one వచ్చేటికి changing the limits also. T is equal to u అన్నాడు. T is equal to u. That implies v is equal to how much? V is equal to 0. T is equal to infinity అన్నాడు. That implies v also infinity. So that is nothing but integral u is equal to 0 to infinity e power minus su f of u du integral v is equal to 0 to infinity e power minus sv into g of, this is nothing but g of g of v into dv. So this one you can write as, instead of this one you can write it as so integral this is nothing but integral u is equal to 0 to infinity e power minus su into f of u into this integral, this one you can write as g bar of s into du. Okay, that means g bar of s you get it as out integration integral u is equal to 0 to infinity e power minus su into f of u du. So this is again in the standard model, that is nothing but the Laplace of f of t model. Therefore g bar of s into f bar of s. So Laplace of phi of t is nothing but f bar of s into g bar of s. But Laplace of phi of t means, what is that one? Laplace of phi of t, f of t into g of t is nothing but f bar of s into g bar of s. So hence convolution theorem is proved. So step by step we will study that one. Okay. So first one, convolution theorem statement is this one. You can write this is in terms of L inverse, this is in terms of the Laplace. So this phi of t f of t into g of t I consider it as phi of t. First step is this one. Okay, first step is this one. Okay, next one వచ్చేటికి Laplace of phi of t. I have applied Laplace to this one. So this is the standard definition. This is the standard definition. Therefore, in place of phi of t, I have written this much. Okay, so both integrals I have written here. Okay, next one, changing the order of integration, you will get like this. So next one, this is changing the limits, you will get like this. Therefore here e power minus st in place of e power minus st, I have written e power minus st and e power minus s into t minus u, because here t minus is there. Therefore I am also writing here t minus u. That is nothing but equal to integral 0 to infinity e power minus sv into f of u dv. Su into f of u du into integral 0 to infinity e power minus sv into g of v dv. So here t minus u is equal to v, I have supposed, and dt is equal to dv. T limits from t is equal to 0, that implies v is equal to 0. T is equal to infinity, that implies v is equal to infinity. So if you did like that, you will get like this. So next, therefore e is equal to 0 to infinity e power minus su into f of u into g bar of s, that is into du. Therefore g bar of s, you get it outside of the integration. Therefore you left with u is equal to 0 to infinity e power minus su into f of u du. That is again a standard definition of the Laplace f bar of s. Therefore Laplace of f of t is equal to f bar of s into g bar of s. But phi of t means f of t into g of t. That is equal to f bar of s into g bar of s. Hence convolution theorem is proved. Okay, thank you. Today we are going to discuss the problems multiplication by powers of s. Multiplication by powers of s. Multiplication multiplication by powers of s. Okay, so we have L inverse of f bar of s is equal to f of t, and f of 0 is equal to 0. Then L inverse of s into f bar of s is equal to f dash of t. This is the formula. So L inverse of s into f bar of s is equal to f dash of t. So consider the first problem. L inverse of 1 by s by 2s square minus 1. So first what you have to do, consider is the except s, you consider it as the f bar of s. Therefore f bar of s is equal to 1 by 2s square minus 1. Second step, you apply the L inverse both sides. So L inverse of f bar of s is equal to L inverse of 1 by 2s square minus 1. That is nothing but equal to L inverse of, you take 1 by 2 as common, therefore 1 by 2 into s square minus 1 by root 2 whole square, that is equal to 1 by 2 into 1 by 2 into L inverse of 1 by s square plus a square. Therefore 1 by root 2 means root 2 into sine 1 by root 2 into t sine at. Therefore 1 by root 2 into t, that is nothing but t by root 2. So that is nothing but 1 by root 2 into sine t by root 2. Sine t by root 2. What is this one? This is the L inverse of f bar of s, that is f of t value. F of t value is, you got it like this. What we have to find out is the L inverse of s into f bar of s is equal to f dash of t. Already we know f of t, therefore f dash of t, how you can find out means L inverse of s f bar of s is 1 by 2s square minus 1 is nothing but f dash of t 1 by root 2 into cos t by root 2 differentiation. Cos t by root 2 again, t by root 2 means 1 by root 2, therefore nothing but 1 by 2 into cos t by root 2. So L inverse of s by s is 2s square minus 1 is equal to 1 by 2 cos t root t cos t by root 2 cos t by root 2. Similarly, we will go for some another problem. So that is L inverse of s by s minus 4 whole power 5. So first step, except s you have to consider it as f bar of s. So f bar of s is equal to 1 by s minus 4 whole power 5. So next applying the L inverse. L inverse of f bar of s is equal to L inverse of 1 by s minus 4 whole power 5. So that is nothing but in place of s you have s minus 4 means e power 4t into L inverse of 1 by s power 5. That is equal to e power 4t into L inverse of 1 by s power 5 means t power 4 by 4 factorial. That is L inverse of f bar of s means f of t value. F of t is equal to this much. So next what we require is the L inverse of f bar of s by s into f bar of s. S into f bar of s is equal to f dash of t. Therefore L inverse of s by s minus 4 whole power 5 is equal to f dash of t 1 by 24 into 1 by 24 into e power 4t into 4t cube plus t power 4 into e power 4t into 4t differentiation is 4. So if you do the simplification, you are going to get the answer. Okay. Similarly, we can discuss division by s. Division by s. We can discuss division by s. So division by s. So division means you have to remember the integration. So we have formula is L inverse of f bar of s is equal to f of t. F of t. L inverse of f bar of s is equal to f of t. Then L inverse of f bar of s by s is equal to integral 0 to t f of u du. Integral 0 to t f of u du. So we will consider the one problem. So what is that one is L inverse of 1 by s into s plus 2. 1 by s into s plus 2. So first you consider f bar of s is equal to 1 by s plus 2. So if you apply the inverse Laplace, L inverse of f bar of s is equal to L inverse of 1 by s plus 2. That is nothing but f of t is equal to e power minus 2t. E power minus 2t. This is the important one. Next one, what you have to do is the L inverse of f bar of s by s is equal to integral 0 to t f of u du. L inverse of f bar of s by s, that means 1 by s into s plus 2 is equal to integral 0 to t f of u e power minus 2u du e power minus 2u du, that is equal to e power minus 2u by minus 2 between the limit 0 to t, that is equal to e power minus 2t by minus 2 minus, in place of u 0, therefore you left with minus 1 by 2, that is equal to 1 by 2 you take common, therefore what you left with is minus minus plus 1 minus e power minus 2t. This is the value of y. So applications to differential equation 1 and multiplication with s and division with s. Okay, thank you. Thank you.